Hey everyone, and welcome back to another video. Identify which of the following compounds has the lowest dipole moment. A. Nitrogen trifluoride, B. Acetylene, C. Ethyl chloride, and D. Hydrogen fluoride. First of all, let's draw the structures so we can understand what is the bonding in each of them. Nitrogen trifluoride. Nitrogen corresponds to trigonal pyramidal geometry whenever it has 3 substituents and a lone pair. So nitrogen trifluoride would correspond to nitrogen with 3 single bonds, 2 fluorine atoms and 1 lone pair, trigonal pyramidal geometry, which essentially implies that it will be polar. And the reason for that polarity is that fluorine is more electronegative than nitrogen, so each fluorine is withdrawing electrons towards itself. So we have individual dipole moments from nitrogen to fluorine, making each fluorine partially negative. Nitrogen will become partially positive, and there's also a lone pair on nitrogen. The dipole moments do not cancel out because the dipole of the nitrogen fluorine bond is pointing towards fluorine in each case, but we also have a lone pair instead of an additional nitrogen fluorine bond. So that means the net dipole moment is not zero, and therefore it is a polar molecule. Moving on to acetylene, we have 2 carbon atoms triple bonded. And then we also have 2 hydrogen atoms bonded to each carbon. We can state that this linear structure, and the reason why it's linear is because we have sp carbon atoms. That would be 180 degrees angle. Specifically, we're going to state that the dipole moment is actually 0 because carbon is slightly more electronegative than hydrogen. So we have 2 dipole moments towards each carbon. They're exactly the same, so they cancel each other out, right? The structure is linear and symmetrical. That essentially means that the 2 dipole moments will cancel out. So we can state that it's nonpolar. Moving on to C, we have ethyl chloride. And since chlorine is more electronegative than carbon, there's an overall dipole moment moving towards chlorine, from carbon to chlorine. And due to the fact that chlorine is more electronegative than carbon, there is a net dipole moment. So the net dipole moment is not 0, and the structure is polar. And finally, we have hydrogen fluoride. Hydrogen fluoride is a linear structure because it consists of 2 atoms. Fluorine is more electronegative than hydrogen, so that the dipole moment exists. It's non-zero. Since fluorine is a more electronegative than hydrogen, it gets a partial positive charge, and therefore the net dipole moment is not 0, and the structure is polar. Well done. So now, based on this analysis, electronegativities, the structure shape, and the dipole moment analysis, we can state that the only structure which is nonpolar is acetylene. If acetylene is nonpolar while all the other molecules are polar, we can state that the lowest dipole moment, in this case the 0 dipole moment, will correspond to the answer choice B. Acetylene has the lowest dipole moment among the given structures because it's nonpolar while the other structures are polar. Thank you for watching, and I hope to see you in the next video.